All right, everybody. Let's do our review real quick. We're gonna write on the side, protons are positive and electrons are negative. So y'all can figure that part out. So when you think about how we talked about conduction is like the toaster. When you have a toaster and a fork, that is conduction, where you don't even need any friction. You just touch the fork to the toaster and it sparks. But induction is when you put a charged object close to another neutral object, and then you touch the object with your finger, and the electrons will move from the object around your body to the finger to the can. So instead of the toaster and the fork just automatically sparking together, induction, you would need a whole thing. And if you know morphology, induction, induce, it means to lead to something. So if you're leading the charge to something versus you're just pressing something. Okay? So we know that polarization is when you have something and you separate the charge into two sides. Like if I said everybody everybody in one side everybody go to one side if you like winter, and everybody go to the other side if you like summer. That's polarization, where everyone is in the same room, nobody leaves, nobody comes in, but you just separate to the sides. Charging by conduction is the toaster and the fork. Grounding is when you have charged objects and they become neutral. And charging by induction is this process. So when the balloon is held near to the pop can and before being touched by the hand, the distribution of charge on the pop can is best depicted by diagram blank. So it says it's an uncharged metal pop can. When you think about uncharged equals neutral. And what does neutral mean? Neutral means an equal amount of positives and negatives. So which answer choices can we take out from there? We can take out C and D because they don't have any equal things inside of the can. Here, we're going to have to take out A because a negative and a negative cannot be next to each other. So B is the only option. For 4, sorry y'all, I'm filming in school today, so it's going to be loud. We know that protons never move. Never, ever, 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 ever move. So we can take out A and B because protons never move. Let me clear the board. Okay, so when the pop can is touched by the hand, blank moves. We know protons never, ever move. And electrons will move. Like we said over here, the electrons will move around your body, around through the finger to the can. So it's moving from the hand to the can. Okay? And if electrons are moving to the can is gaining electrons. If you gain electrons and electrons are more negative, then it becomes more negative, right? So it becomes a negative charge. When the induction charging process is complete, the balloon is... Honestly, I don't know that one. Star it, ask Mr. Music. Number 7. In general, the use of a negatively charged object to charge another object by induction causes the other object to acquire a blank charge. So if I have a negative balloon and a neutral can, and I transfer the electrons to the can, The can is gaining electrons, so it's becoming more negative, right? Now this is different because we don't have a negative charge here, we have a positive charge. And do protons just move like this to the can? No, because protons never move. Protons never move. Ever. 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 If we get that wrong on the test, I'm gonna be upset. They never move. So what happens is the electrons will move from the can to the hand, to the finger, all the way around your body, and then to the positively charged balloon. Okay? And same thing with this one. It needs to be neutral, and a positive can't be together, so it's A. When the pop can is touched by the hand, blank moves. We know that protons never move, ever, 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 unless you're polarizing and they're moving within the system. They can never move outside of their atom. And we already talked about how the electrons are moving from the can around to the positive. So it's moving from the can to the hand, and the can will become more positive because it's giving electrons. So it's becoming more positive because when you take away negatives, for example, let me draw a picture. If I have positive, positive, negative, negative, and I take away those two negatives, all I have is a positive and a positive, so it becomes more positive.